All right, so chapter 4, okay? Chapter 4 looks at visualizing variability with a scatter plot. A scatter plot is a tool to look at two variables, two numeric variables, and see if there's a relationship, When I say scatter plot, the first thing you probably think of is a bunch of dots. And that's a good way to look at it. But the question is, what do those dots represent? And is there a relationship between those dots? Is something going on between those dots? So when you look at a scatter plot, there's a couple things I want you to look at. We're going to look at the form or shape, just two words that mean the same thing. We're going to look at the direction or trend. And we're going to look at the strength. Okay? Three things we can look at when we look at a scatter plot. Okay? So the first thing is the form or shape. Well, let's say our dots, our scatter plot, look like this. Okay? What shape, what do you see in those dots? Those dots are forming a line. Perfect. That would be a linear relationship. And to be honest, all we're going to do is linear in here. Another class I teach called business calculus, we do linear, quadratic, exponential, logarithmic, and logistic. We do 5, all for the first test. Okay? And the idea is that it's just different shapes. So there's linear, but there are other ones in the world, like if it goes up and goes down, that could be a curve relationship, and there's a ton of curve relationships. Does anybody remember a good shape when it goes up and goes down? What shape is that? Parabola, quadratic, right? So that's why there's a whole bunch out there. But again, for us, we're only going to work on linear. We're going to work on linear relationships. Okay? So we look at a bunch of dots, we say, okay, it looks like a line. Well, we can talk more about it. We can also talk about, are they positively associated or are they negatively associated? And that's going in direction or trend. So if my dots were going from left to right up, would that be positive or negative?
Positive.
Good. That would be a positive relationship. And the reason why it's positive is as x goes up, y goes up. Remember, x-axis, y-axis. As x goes up, y goes up. Looking at it from left to right, that's a positively associated relationship. Okay? Well, if the dots are going downward from left to right, that would be a what? A negatively associated relationship. And in that case, what's x doing? X is actually still going up, but y is going down. So as x goes up, and x usually always goes up, kind of like we're talking about time. Time always moves forward, right? As x goes up, y goes down. As x goes up, y goes down. So not only can we look at the shape, we can also look at the direction. And the last one's a little weird. The last one's called strength. And for right now, we're going to be a little black and white about it. We're going to say strong or weak. Okay? Well, if your dots are tightly together, we call that a strong relationship. If your dots are tightly together, we call that a strong relationship. Okay? But if your dots are all over the place, kind of scattered, we call that a weak relationship. Now, there's a million things in between, and we'll definitely talk about strength a little bit later. But for right now, strong and weak. Okay? So the first thing we have to figure out, and kind of this is going to be the theme anytime we do a word problem, is you got to know your input and you got to know your output. You got to know which is x, you got to know which is y. That's the number one most important thing. So most people, they read a word problem, they start working on it, but they have no idea what they're doing because they don't know what the input and the output are. Okay? When we talk about statistics, one way to look at input and output is explanatory response. Okay? Explanatory is our x, our input, our x, our input. And that intends to explain what's going on. I think this is y. Okay? The response is the y, the output. The y, the output. That one says, okay, if this is what it's supposed to be explaining, what ended up happening? What's the outcome? Kind of like cause and effect, sort of, but we say explanatory response. If we decide that it's explanatory response, The explanatory is the X, the response is the Y. The explanatory is the X, the response is the Y. Okay? So we're going to look at some examples, and you have two choices. Choice number one, if you don't think there's a relationship, you're going to write explore the relationship. If you don't think there's a relationship, you're going to write explore the relationship. Or if you think it's explanatory response, then you tell me which is explanatory, which is response. Which is explanatory, which is response. So I'll do the first one with you. The amount of time a student spends studying for a statistics exam and the grade on the exam. How much time you spend studying and the grade on the exam. Do you think that, I don't think there was a relationship, explore the relationship, or do you think it's explanatory response? Good. So as soon as you decide it's explanatory response, then you have to decide which one is which. So which one is explanatory? Good. Time spent studying. That would be your explanatory. That would be me turning off the computer. That would be your explanatory, which is your X. And then what would be your Y? Grade on the exam. Grade on the exam. Grade on the exam. Are we okay? So your choices are explore the relationship. I don't think there's a relationship here. Or you can put explanatory response, tell me which is which. We may have some arguments with some of these, but go ahead and do B, C, and D. And I will tell you that I always like to play music in between, but when we're recording, they've already caught me playing normal stuff, so I have to play like uncopyrighted music. Another minute or so. Okay, so let's go through each one again. We may disagree, we may have different things. Let's see what we say. The weight and height of a person, what would you say? Yeah, I'm gonna put explore the relationship. You can't argue that if someone's taller, they should weigh more, things like that. But there are too many exceptions to say if someone is 5'5", how much are they gonna weigh? Really, there's too many exceptions there. So I probably put explore the relationship, but I can see the argument the other way. The amount of yearly rainfall and yield of a crop, what would that be? That would be explanatory response. Okay, explanatory response. Let's see which one's which. Which one would be explanatory? The amount of rainfall. So how much rain you get, that explains input X, what response? Yield of crop. Yield of crop is how much crop you get. Okay? And again, that's probably a linear one, more rain, more crops, but you can also think of it as maybe quadratic. The more rain you get, the more crops, but at a certain point, what happens if you get too much rain? You'll lose crop, flooding, all your crops are gone, okay? And then the last one, a student's grade in statistics and a student's grade in Spanish. Yeah, they're gonna put explore the relationship, but again, you could argue the other way. You could argue that if you're a good student, the same skills you do for statistics, you can do for Spanish. You can also argue that they're both foreign languages. Right? Okay, so if it's explanatory response, X is explanatory, Y is response. If it's explore the relationship, you're gonna have to pick one to be your X and one to be your Y and see how it goes. Okay, so flip the page. Now we're gonna use some real data. And we're going to work on it. Okay, so what you have is real data from 1977 to 1990. This one talks about manatees. Raise your hand if you've actually seen a manatee live, not on TV. Okay, about half of you, a little more, 3/4. Good. You live in Florida, they're everywhere. If you have not seen a manatee, please go see a manatee. An example, a good place to go is on a cold morning. Go to Blue Springs, it's probably like 45 minutes to an hour away. You'll see hundreds of them. They're all over the place, right? Because when it's cold, the manatees come into the springs where the water is like a normal 70 degrees, right? So they come into the springs. Also, there's a place called Homosassa Springs, Crystal River sort of thing. It's the only place in the world where you actually can touch manatees. You can't really touch them. They really hate when you ride them. But it's a really cool place. You can literally get a canoe or a kayak and you will see hundreds of them. They'll go under your kayak and stuff. It's really, really cool. It's probably about an hour away towards Tampa. Okay, so here's some information from 1977 to 1990. The first column talks about powerboat registrations in thousands. So just give you an example. In 1977, 447,000 powerboats were registered. 13 manatees were killed. In 1990, 719,000 powerboats were registered. 47 manatees were killed. We okay? So don't say it out loud, but I want you to look at the data. First, decide which is explanatory, which is response. That is step one, most important. Got to do that first. Okay, so which one is explanatory? Good. Power boat registrations, we know it's in thousands. That is going to be our X, our input. Our X, our input. We're trying to say how many powerboats Florida registers explains what response? Good. How many manatees, or number of manatees killed That's going to be our Y, our output. Everything starts with that. If you run to your calculator, you've already messed up. You've already messed up. You've already messed up. You got to understand the problem first. That's usually the biggest mistake people make, is they don't stop and understand the problem. Now, you may be wondering about the year part. The year kind of puts the data in order. So when you look at it left to right, you actually see over time. Okay? So, again, not touching my calculator, The very first thing we're going to do is I'm going to sketch this thing out. And again, without this step, that's where people go wrong. They hit graph and see nothing because they don't know what the data should look like. So we know our x-axis is power boat registrations. And we know that our y-axis is number of manatees killed. Number of manatees killed. Okay? Now, the reason why we have to sketch it out first is I got to understand the data. I got to figure out where I'm going to start, where am I going to end, and what am I going to count by. Where am I going to start, where am I going to end, and what am I going to count by. Same thing for number of manatees killed. Where am I going to start, where am I going to end, what am I going to count by. The calculator doesn't do it for you. Yeah, there's a thing called Zoom 9 that kind of does it for you, but it does whatever it feels like. We want to control that. We want to understand the problem. So looking at power registrations, take a minute, literally a minute. Don't write it down, just in your head. Where would you start? What number? Where would you end? What number? And what would you count by? There's not one singular answer, which you're learning, that's the way statistics works. But try to figure out if I was going to do this, where would I start? Where would I end? And what would I count by? What would I count by? So don't write it down, just kind of think in your head. Looking at the data, where would you start? Where would you end? And what would you count by? Okay, looking at the data, what number would you start with? 400 would be a good one. 440 would be good. Would you start at 0? No, there'd be all that wasted space. So that's kind of around that, 400, 440, 425, somewhere around there. What would you end with? 730, 740, 750, maybe even 800. You wouldn't end at 1,000, right? Because you'd have all that wasted space. Now, here's where the decision is really going to happen. What do you want to count by? So if I decided to go from 440 to 730, that's great. You're going to count by ones, tens. That's going to take forever. So yes, there are millions of answers, but make life easy for you, right? There's a saying that says, work smarter, not harder. That was said by Scrooge McDuck. Okay? DuckTales, nobody knows. All right. So what happens is, if we're going to start and think about the scale, I'm going to start at 400. And I'm going to go to 750 so I can count by 50s, right? Because I don't want to sit here forever and put down tens. I don't want to sit here forever and definitely don't want to do ones. So it takes a little planning. It takes that thing called thinking. It hurts. I know it's early, but it's super important. Okay? And again, if you decided to go from 420 to 730 by tens, you're absolutely correct. I wouldn't mark it wrong. You're totally right. There's not one answer. As long as you're a little bit before, as long as you're a little bit afterwards, as long as you made a good scale, you're great. So you don't have to copy me, but understand you don't want to make life hard for you either. Okay? Let's do the same thing. Do it in your head first. Look at manatees killed. What would you start with? What would you end with? What would you count by? What would you start with? What would you end with? And what would you count by? In your head, just for a second. Okay, looking at the data, the lowest is 13. What would you start with? 10. 0 is even okay, right? The highest number is what? 50, not 47, 50. So what should we end with? 55, 60, right? So for me, and again, make sure you start on the corner. Some people start out, I start around the corner. I'm going to start with 10, and I'm going to go by 10s, and I'm going to go up to 60. Okay? If you had a different idea, going from 5 to 55 by 5s, fantastic. That's wonderful. Okay? There's not one answer. As long as you're a little bit before, as long as you're a little bit afterwards, no problem, no problem. We okay? Questions there? Now notice, I still haven't touched my calculator at all. But we're missing the dots. I could sit here and put all the dots, but is that going to be fun? Probably not. So we're going to start doing this in the calculator. Okay? So let's see how much we remember. I want you to put powerful registrations in list 1, and I want you to put manatees killed in list 2. Before you get started, just look up for 1 second. Every time you want to make sure you have a clean calculator. What does that mean? Everyone go to y equals. Make sure there's nothing in y1. If you happen to have a plot or two on from your last exam, turn those plots off. Always start with a clean calculator. Your plots should be off. Nothing in y1, nothing in y2. Once you have a clean calculator, then put your data in the calculator. See if you remember how to put your data in the calculator. If you have any questions, just bring it on up or raise your hands. I'm going to put the data in the calculator as well. But this is stuff we know how to do. So make sure we don't forget. And not to scare you, but if one number is wrong, the whole thing's wrong. So it's nice that we have a calculator, but the condition is you got to type it in right. Like we've done, go back and check. Step 1, put the data in the calculator. Step 1, put the data in the calculator. Okay. Now, step 1 is to put the data in the calculator. I put all my X's in list 1. I put all my Y's in list 2. Question so far? Keep it straight, especially when you're going to do your MyStatLab homework. You better be really certain where's your X, where's your Y, because it's not always left and right. It could be backwards, right? So know which one's which. It's usually where little mistakes happen. Okay. Now, step 2. Just like with all the pictures, just like a histogram. We go to second y equals. Notice you have plot 1, plot 2, plot 3. We're only doing one picture. So we push 1 for plot 1. Turn plot 1 on. And scatter plot is the very first picture. Okay? Notice I'm going a little faster because we know how to turn it on. We've done histograms before. We should be getting comfortable with the calculator. The second picture is a scatter plot with the dots we connected with line. We don't want it connected. We just want the dots. Are we okay? Then we do X, which for me is in list 1, you too probably. Y is list 2, double check that. And then you get to choose, do you want your dots to be a box, a plus, or a dot? I prefer the box. So make sure your plot is on. You chose scatter plot. X is list 1, Y is list 2. Questions there? Good? Now, don't do anything, don't do anything, don't do anything. Just watch. Some of you who've used your calculator before, and I taught you, zoom 9. Don't do anything, just watch. Let's see what would happen if I hit zoom 9. If I hit zoom 9, will it give me a nice picture? Yeah, it does give you a nice picture, okay? But the problem with zoom 9 is it does whatever it wants. So you have no idea what these lines mean. Yeah, you see the dots, but you have no control. So don't do anything, just watch. When I press window, let's see what they did. They went from 419.8 to 746.2, counting by tens. Does that make any sense at all? They went from 6.71 to 56.29, counting by hundreds. There's not even 100 between those. So zoom 9 does work, but it doesn't work well. Does that make sense? Now all of you push window, 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 top row. And now look at your paper. This is why we do it first. Looking at your paper, the way it works is X minimum is with the lowest X, X maximum, the highest X, and then X scale, SCL, that's what we count by. So for us, we're going from X minimum of 400, X max of 750, and our scale is going by 50s. So X min, X max, X scale. Looking at our Y's, we decided our Y minimum is 10, our Y maximum is 60, and our scale is by tens. You don't need resolution, you don't need to worry about the stuff below, you're good there. So step 1, put the data in the calculator. Step 2, tell the calculator we want a scatter plot of list 1 and list 2. Step 3, make your own window. Don't use zoom 9, make your own window. And then the last step, hit graph. The last step, hit graph. There's your dots. And I'll tell you, it's a horrible feeling on the test when you hit graph and see nothing. And odds are you didn't do your window. That's usually the mistake, right? Or you have 2 plots on or something weird. Push the trace button for me. Trace, top row, trace. If you do trace and left and right, it looks like the dots kind of jump around, but they're really going in the order of your data. Whatever order you put it in, that's how it goes. So it's actually going over time, and you can see each individual point. Okay? So do your best. Doesn't have to be perfect. You don't have to be an artist, but draw the dots you see. I'm not going to take out a ruler and check every little dot to make sure they're exactly where they're supposed to be. But just get the idea, and then answer the questions below. Trend, shape, strength. Trend is also direction. Shape is also form, and then strength, and then answer the question below. Okay, let's start with shape. What shape do you think it is? Linear, right? Pretty much all we've really focused on is linear. Trend or direction, what is that? Positive. And that's pretty much tied to what it's asking here. What does the relation look like? It looks like as what? Good. As powerboat registrations increase, but what? Good. The number of manatees killed increases. Okay, that is a positive relationship. So far, we can say we have a positive linear relationship, that says the more powerboats you register, the more manatees you're killing. Bad state of Florida. Okay? Now, strength you probably got a little awkward about, but if you had to pick strong or weak, that's all we got so far. Strong or weak, which one is it? Do you see a line? Yeah. Then it's strong. Okay? Now, I know that's not a great answer, and that's not a great answer on purpose, right? There's a million things between strong and weak, right? So we're going to take care of that right now. But again, there's always going to be little calculator steps that you can follow to help you with your stuff. Okay? Now, we don't like saying strong or weak. We don't like saying strong or weak. We want a number. Question? Technically, yeah. It's definitely not weak. And you'll see why in a minute. So, for strength, we actually have a number for strength, and that number is correlation. The number is correlation. Okay? Correlation is a number that measures strength, but only if it's linear. Only if it's linear, and only between two numerical values. Okay? So you can do correlation, but it has to be linear. You can do correlation, but it has to be linear. The letter for correlation is the letter R. The letter for correlation is the letter R. And you're like, why is correlation R? Why isn't it C? Well, C was already taken. Okay? Remember when you do quadratic formula, A, B, C, C is the number at the end, right? So we do R. Why do you think it's R? There's two R's in correlation, right? So that's probably where they got it from. It's just a guess. If you have a bad memory, just remember raw relation. Okay? Big things to remember. Correlation is always between -1 and 1. That's huge. Correlation is always between -1 and 1. I'll explain what that means. Correlation is always between -1 and 1. It only works if it's linear. If your correlation number is negative, it's because you have negative association. If your correlation is positive, that means you have positive association. So if your dots are going downward, left to right, you're going to get a negative correlation. If your dots are going upward, left to right, you're going to get a positive correlation. The positive or negative directly relates to is it going up or going down. Okay? And then in huge letters it says correlation does not imply causation. Correlation does not imply causation. That's actually a lot of problems for people because just if two things are correlated, even if they're super crazy correlated, like really, really strong, it doesn't mean one caused the other. It doesn't mean. You're looking at two numbers and you're throwing them in your calculator. That does not mean one caused the other. Okay? There's a lot of stuff we can talk about later. Now, to find correlation by hand, that's the formula. Does that look fun? It's not. It's long, tedious. You can totally do it by hand, but we're going to do it on the calculator. But you have to take each x minus the mean of the x's divided by the standard deviation of the x's, each y minus the average of the y divided by the standard deviation of the y, multiply those, add them up, and then multiply by 1 over n minus 1. It's just remember that standard deviation one? We did that on purpose to show you how it's really just long and tedious. It's not impossible, but we're going to let the calculator do it. Are we okay? So, before we move on, let's make sure we understand correlation. Correlation is always between -1 and 1. Correlation is always between -1 and 1. Because -1 is a perfect, literally a perfect straight line going downwards. You cannot be stronger than -1 going downwards, right? -1 is perfect. That's a perfect straight line. Positive 1 is a perfect straight line, but going upwards. Anytime I close the projector, it's because I want you to use your imagination. Okay? It's going upward. Okay? So basically, -1 and +1 are the strongest you can be. And in reality, 1 is the strongest you can be. Negative just means going downward. Positive means going upward. Are we okay? So if -1 and +1 are perfect strong, what's weak? Good. Close to 0. Close to 0. What do you think 0 looks like? All over the place. So you're going to get correlations, and then you can make decisions. So if I had a correlation of 0.9, what does that tell you? It's strong and it's positive. Now, it's not going to be a perfect straight line. 0.9, just to kind of show you an idea, 0.9 is probably going to look something like this. Is that still strong? But is it a perfect straight line? No. So what happens is the weaker it gets, the more spread out it is. So if I have -0.2, kind of picture that in your head, what would -0.2 look like? -0.2 would be what? Kind of going downward, but super what? Super weak, super spread out. So like a -0.2 would look something like this. See how it has sort of a going downward look to it, but it's really spread out. Okay? And there's a million things in between. But all you need to know is if it's close to 1 or -1, that's strong. And the stronger it is, the tighter it is. The weaker it is, the more spread out it is. Does that make sense? Okay? Now on the next page, we have some examples. But I'm going to go back to them in a little bit because I really want to continue working. So the question is, how do you find correlation in the calculator? How do you find correlation in the calculator? To find correlation in the calculator, I want you to everyone press stat. Okay? So everyone push stat. I want you to go to the right for calculate, to the right for calculate, to the right for calculate. I want you to scroll up and down and find correlation. I want you to scroll up and down and find correlation. Scroll up and down and find correlation. Where is it? It's not there. There's no such thing. Okay? There's no such thing as a correlation button. There's no such thing as a correlation button. But I'm not mean. I didn't make you do that for nothing. The answer is there. Where is it? Not 2 variable. Not 1 variable. Linear regression. Remember one of the things I highlighted? You can only do correlation if it is what? Linear. Now, if you're looking closely, you'll notice that there's a number 4 and there's a number 8. Number 4 and number 8. So let's take care of that right now. Okay? So let's take care of it. Again, they have all these pictures of correlations and stuff. But let's take care of that right now. Number 4, linear regression says a plus bx. Oh, sorry, number 4 says ax plus b. Okay? Number 8, linear regression, says a plus bx. Okay? Let me explain clearly. Number 4 and number 8 are both good. Number 4 and number 8 are both good. Number 4 and number 8 are both good. They're just preferences. They're just preferences. They are exactly the same. So what do I mean by that? What I mean by that is this. If you had some made up data, and I used number 4, I would get something like y equals 2x plus 2. I'm just making that up. What's the slope? 2 over 1, 2. What's the y-intercept? 3. So A is 2, that's your slope. B is the y-intercept. If I use number 8 on the same exact data, I would get y equals 3 plus 2x. What do you notice? They're exactly the same. They're exactly the same. In the first example, the slope is 2. In the second example, the slope is still 2. In the first example, the y-intercept, you remember y equals mx plus b. The y-intercept is b, which is 3, and here the y-intercept is still 3. They're exactly the same. The only difference is, do you want the slope in the front, or do you want the slope in the back? And does it really matter? No. But I will warn you on my stat lab, if this is the form they want, you can still use number 4. But what happens if you put 2 here and 3 here? It's wrong. So be careful where the x is. Be careful with the x. I get a lot of questions on like, my stat lab doesn't know what it's doing. I'm like, hey, put it in the wrong place. Okay? So that's generally what happens. But please understand, maybe like, I like this one, and you like this one because you were drilled y equals mx plus b, y equals mx plus b. And that's fantastic. We'll use number 4. But if you wonder why we're using number 8, let's remember how to graph. When you graph something, what do you do first? The y-intercept or the slope? The y-intercept. The y-intercept is 3. So I go up 3, put a dot. What's the slope? 2 over 1. So up 2 over 1. When I just did this graph, what did I do first? What did I do first, the y-intercept or the slope? That's why they put it in front. You do the y-intercept first, and then you do the slope second. So this is valuable. And a little side note, do you know why it's called y equals mx plus b? Did anybody tell you why? One theory is b is where you begin. B is where you begin, and m is how you move. M is how you move. That's one theory. Okay? You good? So for us, let's just use number 4. But again, do I care if you use number 8? Not at all. But let's use number 4 because that's what we're used to. Now, depending on your calculator, when you choose number 4, it's either going to look like this, where it asks for list 1 and list 2, or I don't have the other one. Does anybody have the other one? Where it's just blinking? Thank you. Or it's just blinking. Okay? Or it's just blinking. Both of them are great. Okay? If your calculator looks like this one, X is list 1, Y is list 2, go down to calculate, push enter. If yours looks like this, it still wants to know what list. So do second 1 for list 1, second 1 for list 1, and then comma. Comma is above the 7. Comma is above the 7, list 2. Yes, if you just push enter, it defaults to list 1 and 2, but we want to put the list in because we're not always going to use list 1 and list 2. Push enter. Now, you'll also notice, I'm just going to borrow your calculator for one more second. You'll also notice that both of them have A and B, but this one has R squared and R. Okay? Do we need the R? Yeah, we need correlation. So if your calculator looks like this one, and it doesn't have the R squared and the R, you follow me one time. Okay? You don't have to do it all the time. It's a one-time only unless you reset your calculator. If you want to follow me just for fun, even if it says R squared and R, I'm going to make sure everybody gets R squared and R. Okay? So if you want to follow along, everybody push second 0. Second 0. Second 0. Second 0 is your catalog. Everything your calculator can do is in the catalog. Once you get to the catalog by hitting second 0, press and hold the down arrow. Press and hold the down arrow until you get to diagnostic on. Diagnostic on. Put your little arrow on diagnostic on. And again, if you do it, it's not going to hurt anything. Put your little arrow on diagnostic on. Push enter and enter again. Push enter and enter again. And you can hold the down arrow and go a little faster. Enter and enter again. It looks like nothing happened, but now do your linear regression again. Let's see how good your memory is. Do a linear regression again. Okay, stat, calculate, linear regression, number 4. Everybody should have R and R squared. Now, when I ask for strength, you can tell me R. What's R in this case? 0.94. 0.94. Is that strong or weak? That's pretty strong. Why is it strong? Close to 1. And is it going upward or downward? Upward, because it is positive. So correlation tells you a lot of stuff. Okay? If you're wondering what R squared is, we're just going to write these down so you have them. And again, we're going to do more examples. Just getting you all set up today. But R was 0.94. We've had a good discussion about that. And then R squared is 0.886. What the R squared tells you, that's your coefficient of determination. That says 88.6% of the data is explained by the line. 88.6% of the data is explained by the line. 88.6% of the data is explained by the line. Now you're like, what line? I'll explain that in a minute. But we said that the data looks like a line, correct? We said that the data looks like a line. Well, your calculator does something called linear regression. You just did it. Linear regression means it takes every single dot, and figures out where can I put a line that's the least distance from every point. Where can I put a dot? So if we did it by hand, we'd pick 2 points, we'd find the slope, find the y-intercept, make a line. Your calculator takes every single dot and makes a line. Now, will that line hit every single dot? Will a line hit every single dot? No, the dots are spread out. But I can tell you that the line I'm about to give you represents about 88.6% of the data. Not all of it, but a good chunk of it. Is that pretty good? That's pretty good. Okay? Now, back to what the line is. Well, if I go to stat, calculate linear regression, in a matter of a second, it looks at every single dot and determines where the line should be. Just like that. Now, notice on the top, it gives you the formula. Y equals AX plus B. Your job is to put in A for A, B for B. A for A, B for B. A for A, B for B. Are we okay? And you have to round. My answer is always round appropriately. My answer is always round appropriately. So if you round it appropriately, I'd say probably Y equals 0.125 X minus 41.43. So again, when I say round appropriately, 2, 3, 4 decimal places, 2, 3, 4, or it could be 6. It depends on the number. But generally 2 or 3 decimal places is good. My stat lab sometimes likes 4, but they are pretty specific. They are pretty specific with what they want. Are we okay? Now what is that? It's a line. It is a line that should do what? Go right through the data. How can I check if that line goes through the data? Okay, we're going to go to our calculator, go to y equals, top left, y equals, and let's type in 0.125x, 0.125x, when the x is located right here, subtraction 4143. Subtraction 4143. Don't forget the x. Make sure the decimal's in the right spot. If you hit graph, what should you get? The dots and the line goes down the middle. Did anybody not get the dots and the line that goes down the middle? If you didn't get the line, go back and check. Did you put 0.125x subtraction, not negative, but subtraction, 4143? Yeah.
So the R just kind of tells us what we're going to see.
The R kind of tells you if it's strong or weak. So for example, in reality, is this R strong? Yeah. That would tell me there's something going on here. I don't know for sure because correlation doesn't imply causation, but I'm going to spend some money in some experiments on this. That's what I'm going to do. So if the correlation was like 0.2, would you move forward and really spend time on this? Probably not. Does that make sense? So that's kind of where we use that. Does everybody have the dots on the line that goes through it? Now, there's a million other things that I need to teach you, but we're going to stop here for a second. And the goal was to make a graph of the dots and a line that goes through it. Are we okay? So go back into that original picture. You have the dots, and now you can put the line that goes through. There's still a bunch more to teach about this manatee problem. We're not done with the manatee problem, but I think it's a good place to stop and give you some practice. So for next class, I want you to keep on flipping pages until you get to GPA and TV hours. So I'll get you started. And what I'd like you to do, go to GPA and TV hours. All I want you to do right now is pick which one is your explanatory X, which one is your Y. Which one is your explanatory X, which is your Y. That's always, always, always step one. That's always, always, always step one. And again, I'll just set you up. So, which would be our X? Good. Some people say it's always GPA because it's on the left. Is X always on the left? No. So we're trying to say our explanatory, our X is TV. How much TV you watch explains what response? The GPA. Now, not right now. You're going to do this at home because I'm not going to see it until next week. TV, you're going to put in list 3. GPA, you're going to put in list 4. Are we okay? Now, look up. You should not touch your calculator until you do what? You should sketch it first, figure out your window, figure out all that stuff. Then you go to your calculator, get the dots. Then you're going to answer the question, form, direction, strength. Along with strength, you can find your R and your R squared. And I also want linear regression. So for next week, you're going to work on kind of the mechanics, the how to get the dots, how to get the line, how to get the dots, how to get the line. Next class, we're going to talk about what everything means. What does the slope mean? What does the line intercept mean? How do we use it? What's going on? We'll go back to the manatee example, and we'll definitely go back to this example. But what I want you to do from now until next week is you can totally do the manatee example again. That's in list 1 and list 2. But then also work on the GPA and TV hours. So at least I know when you come back, the dots and the line you're comfortable with, then we focus on the moving. Okay?